Let's go over section 1.6. What values of the variable cannot possibly be solutions for the given equation without actually solving the equation? To do this question, I want to set each of the denominators equal to 0. 3x plus 5 equals 0. And then I want to set x minus 7 equal to 0. Now the reason we're doing this is you cannot divide by 0. It is undefined. So we must exclude the fact that the denominator cannot be equal to 0. To solve the first equation, let's subtract 5 to both sides. 3x equals negative 5. Divide both sides by 3. X is negative 5/3. On the other side, we'll add 7 to both sides. X equals 7. So we must exclude these two solutions. X cannot be equal to negative 5/3 and x cannot be equal to 7 because you would be dividing by 0 and that's undefined. In question 2, it's the same process, but before I start, let's factor the denominator here. We have negative 12 on top and a 1 on the bottom. This has numbers that would multiply to get negative 12 and add up to 1 as 4 and 3. This has to be a negative 3. So this right here factors as x plus 4 and x minus 3. Now to find out what solutions cannot possibly work, we set again the denominators equal to 0. X minus 3 equals 0. Or x plus 4 equals 0. Now I don't need to set this equal to 0 because it's going to yield the same solutions as these two. So we can solve for x. X is equal to 3 or x is equal to negative 4. So we must exclude these two solutions. X equals 3 and x equals negative 4 cannot possibly be solutions. They would cause the denominator to be equal to 0 and you cannot have that. Question 3, let's actually solve an equation. We have 2x plus 3 over 2 minus 3x over x minus 3 equals x. Now I know that x cannot be equal to 3. The reason we know that is the denominator. If I set x minus 3 equal to 0, I would have x equals 3. Now you cannot divide by 0, so we have to exclude x equals to 3. Now let's solve this. I want to find the LCD first. The LCD is 2 times x minus 3. I'm just taking pieces of the denominator to make my LCD. Now we'll take the LCD, 2x minus 3, and we'll multiply it to every single term. So it's 2x minus 3 times the first term, 2x plus 3 over 2 minus 2x minus 3 times the second term, which is 3x over x minus 3, and that's equal to 2x. That's equal to 2 times x minus 3 times x. Let's see what cancels out. We have the 2 cancels out with the 2. The x minus 3 divides out with the x minus 3. And that's it. So let's FOIL everything out now. We can FOIL this out. So x times 2x is 2x squared. This becomes 3x. We have negative 6x and negative 9. So this is FOILing out the left side. Now let's look at the middle. This becomes negative 6x. Now I can distribute the 2 here and distribute the x. So that gives me 2x squared minus 6x. Now let's collect like terms. I can add these two together, or actually these three together. So that gives us 2x squared, 3x minus 6x minus 6x again, that's negative 9x minus 9 equals 2x squared minus 6x. Let's subtract 2x squared to both sides. Hey, what do you know? They cancel out. And now we can solve for x. So let's add the 9x to both sides. I have negative 9 equals 3x. Let's divide both sides by 3. X equals negative 3. Now, is this a good solution? We have to check. We know we cannot have x being equal to 3, but negative 3 is a good solution. So we're going to keep this solution. It's a good solution. Question number 4. Let's solve the equation x over x minus 8 equals 8 over x minus 8 plus 9. Now, what's my LCD? The LCD is the pieces of the denominator. We have x minus 8, and that's it. We don't need two x minus 8s because the LCD has to be divisible by each of the denominators. X minus 8 already divides into x minus 8. I do not need to add any more terms to my LCD. Now we can multiply x minus 8 to each and every single one of the terms. We have x minus 8 times the first term, x minus 8 times the second term, and x minus 8 times the third term. X minus 8 times x over x minus 8, x minus 8 times 8 over x minus 8, and x minus 8 times 9. Now let's see what divides out. This divides out with this one. This divides out with this one. And we have left over x equals 8. And we'll distribute the 9 here on the right. That's 9x minus 72. Let's collect like terms. X equals the 8 and the negative 72 gives me negative 64 plus 9x. Let's subtract the 9x to both sides. Negative 8x equals negative 64. And I can divide both sides by negative 8. So x equals 8. Now some people might think that's our solution. But we have to check. Does it cause our denominator to be equal to 0? Yes, it does. So this is not a good solution. It causes our denominator to be 0, so we got to throw it out. So our answer is no solution. Question number 5. Before we start the question, let's factor out the denominator. We have 6x plus 1 over x minus 2 plus 4 over x equals negative 8 divided by x times x minus 2. We use the GCF method for the denominator here. Now what's our LCD? Our LCD is going to be every piece of the denominator. And so we have x minus 2, x, and we don't need to repeat our terms, so this is it. This is our LCD. We have x minus 2 times the first term, x minus 2 times the second term, and x minus 2 times the third term. So we have x times x minus 2 times 6x plus 1 over x minus 2 plus x times x minus 2 times 4 over x. And finally, we'll multiply it by the last term. There's a negative here, so be careful with that negative. Now let's see what divides out. We have x minus 2 divides out. This x divides out with this x on the outside. This x divides out with this x. X minus 2 divides out with this x minus 2. Now I'll still have to distribute this x to 6x plus 1. That gives me 6x squared plus x, and this 4 will have to distribute to the x minus 2. That gives us 4x minus 8, and that's equal to negative 8. Let's collect like terms. I have 6x squared. These together make 5x, and then we have a negative 8. Let's add 8 to both sides. Those do cancel out. And so we have 6x squared plus 5x is equal to 0. I can factor out the GCF here, that's x. That gives us 6x plus 5 equals to 0. And so x could be equal to 0, or x could be equal to negative 5 over 6. Again, I get that by setting each of the factors equal to 0. But you have to check. X equals 0 does not work because it caused this part of the denominator to be 0. But if you plug in negative 5 over 6 into each of the denominators, that does not happen. They do not become 0, so we know this is a good solution. Sally can paint a room in 4 hours, while it takes Stephen 9 hours to paint the same room. How long would it take them to paint the room if they worked together? To do this question, let's make ourselves a table. We have Sally, and we have Steve. Now, I like to put the alone time in the table. How long does it take Sally to do the entire room alone? It takes 4 hours. What about Steve? It takes him 9 hours. Now, on the top here, we'll put the rate, the time, and the amount of work that they each do. Now, remember, if Sally can do the entire room alone, she could do 1/4 of the room every hour. Same thing with Steve. If he could do 9 hours for the entire room, he does 1/9 of the room every hour. You always take the reciprocal of their alone time. Now, since they're working together, they will complete the job at the same time. I don't know what that is, so we'll call this X. We'll call this X for both cases. And remember, to find the amount of work, we multiply by the rate and the time. So this becomes 1/4 X. And 1/9 times X is 1/9 X. Now we want to add their work together. So 1/4 X plus 1/9 X should equal 1 completed job. Now I don't like these fractions. I want to get rid of those fractions. What's the LCD? The LCD is 36 because we are multiplying 4 times 9 together. We'll multiply 36 times 1/4 X, 36 times 1/9 X, and 36 times 1. This gives us 9x plus 4x equals 36. I can add 9x plus 4x. That is going to give me 13x. 13x equals 36. Divide both sides by 13. And so x is equal to 36 over 13 hours. It would take them about 36 over 13 hours, or approximately 2.77 hours to paint the same room. For question number 7, again, we'll make another table. We have 2 individuals. Andrew can paint the neighbor's house 6 times as fast as Bailey. The year Andrew and Bailey worked together, it took them 5 days. How long would it take each to paint the house? Now we have 2 individuals. We have Andrew and we have Bailey. Let's look at their alone time, the rate, the time, and the amount of work. Now we don't know how fast Bailey can paint the house or Andrew can paint the house alone, so we'll have to give these names. We know Andrew can paint the house 6 times as fast as Bailey. So one of these has to be X, and one of these has to be 6X. Andrew should get X, and Bailey should get 6X. Now think about it for a moment. Andrew can paint the neighbor's house 6 times as fast as Bailey, which means he's faster. So pretend X is 1 hour, Bailey would take 6 hours. So don't get that confused. Some people think Andrew should have 6X and Bailey should have X, but remember, Andrew's faster. So this should be a smaller number than this number. So X should be Andrew and Bailey should be 6x because he's actually 6 times slower. Now what's the rate? Well, the rate is always the reciprocal of the alone time, so we'll put 1 over x here and 1 over 6x here. What's the time? Well, it took them 5 days together. So let's say each of these should be 5. Now to find the amount of work, we multiply across. This is going to give me 5 over x, because 1 over x times 5 is 5 over x. 1 over 6x times 5 is 5 over 6x. We will take 5 over x plus 5 over 6x and set that equal to 1 because that represents one complete house. Let's find our LCD. Our LCD should be 6x. Now we can multiply the 6x times every single term. This gives us 30 plus 5 equals 6x. Or 35 equals 6x. I could divide both sides by 6, and x is equal to 35 over 6. Or we can convert that. Or we can convert this to a fraction. This is equivalent to 5 and 5 over 6 days. So this is the amount of days it would take Andrew to do the job alone. Because Andrew is x, we know it's going to take him 5 and 5 over 6 days. Now for Bailey, we would have to multiply this number by 6 to figure out how long this individual will take. So what's 6 times 35 over 6? It would take Bailey 35 days to complete the house alone. So 5 and 5, 6 days for Andrew, and 35 days for Bailey. That's incredible. Question number 8. Let's solve the equation. First thing I want to do is isolate that radical. Let's isolate that radical and then we can solve for it. So let's add the square root of 32 minus 4x to both sides. We'll add the square root of 32 minus 4x to both sides. This would cancel out, and I get x equals the square root of 32 minus 4x. After this, make sure you square both sides. This will get rid of the radical. X squared equals 32 minus 4x, and now we can set this equal to 0 and try to factor. Let's subtract 32 to both sides, and we'll also add 4x to both sides. This simplifies as x squared plus 4x minus 32 is now equal to 0, and let's use the diamond method. Have negative 32 on top, 4 on the bottom. We know the two numbers are going to be 4 and 8. This has to be a negative 4. It factors as x minus 4 times x plus 8 equals 0. And so we have two possibilities. X could be equal to 4 or x could be equal to negative 8. But you're going to have to check that these solutions do work by plugging them in to the original equation. So check that on your own. Plug these into the original equation and see if they work. So we'll check x equals 4 first. And I'm just plugging in a 4 for the x. We have 4 minus, inside this radical here, that's 32 minus 4 times 4, or the square root of 16. And that does work. The square root of 16 is 4, and 4 minus 4 is 0. So x equals 4 is a good solution. Let's check negative 8. Is that a good solution? So this is negative 8 minus the square root. We have 32 minus 4 times negative 8. That's positive 32. So that's positive 64. So we have the square root of 64 is going to give us 8. but there was a negative in front, so we'll have to do 8 minus 8, and that is not equal to 0. That's negative 16. So we know that x equals negative 8 is not a good solution. And so we have, there's only one good solution, and that's x equals 4. Question number 9. I am going to again isolate that radical if possible, and it's already done for us, so we don't have to worry about that. Let's now square both sides. That gives us 7x plus 74 equals, now we'll have to FOIL out 3x plus 6 times 3x plus 6. We have 7x plus 74 is equal to, this is equal to 9x squared plus 18x plus 18x plus 36. So let's collect like terms. 7x plus 74 is equal to 9x squared plus 36x plus 36. Let's subtract 7x to both sides, and we'll also subtract 74 to both sides. We get 0 is equal to 9x squared plus 29x minus 38. Now we might be tempted to try to use the quadratic formula, and you can use the quadratic formula for this problem, but I would recommend trying to factor first. This is going to be the AC method, and so we'll multiply 9 times negative 38. That gives us negative 342, and we'll have to find the two numbers that work. The two numbers that work are 9 and 38. It is actually a negative 9 and a positive 38. So let's split the middle. Since this is the AAC method we're going to do here, we're using the AAC method. So we'll write this as 9x squared minus 9x plus 38x minus 38. Now we can factor out the GCF. I can take out a 9x, and that leaves us x minus 1. For this one, we'll factor out a 38, and that leaves us x minus 1 again. So we can finally factor out the x minus 1 to the front, and that leaves us 9x plus 38 equals to 0. So we can set both of these equal to 0. X could be equal to 1, or x equals negative 38 over 9. But you want to double check that these two solutions do work. So plug it into a calculator and plug it into the original equation to make sure both sides are equal. And they do work, so these are two good solutions.